Now, welcome back. Let's look at question number 8. Question number 8 says that solve for 4 tan square of 2 theta minus 30 plus 1 is equals to 49, giving the answer to one decimal place. So that is the instruction. Now, if we start with the question Roman 1, rewriting this down here, Roman 1 will have 4 tan squared of 2 theta minus 30. This one should be equals to 48, because if you take the other side of the equal sign, it will be 49 minus 1. Simplifying this further, we can reduce both the left hand side and right hand side by 4. So divide this one by 4 so that what we are going to have is tan squared of 2 theta minus 30, and this one should be equals to 48 divided by 4 is equivalent to 12. Now for us to remain with only tan, then it means we need to get the square root of both the left hand side and right hand side. So if we apply the square root here, then it means what we are going to have is tan of 2 theta minus 30 equals to plus or minus the square root of 12. Now we can get the basic angle to use, but in this case we are going to look at the two options for positive root 12 and also negative root 12. Maybe if we start with the first one, we'll have tan of 2 theta minus 30 equals to positive root 12. We can get the basic angle in this case by getting the tan inverse of root 12. So therefore we'll say that 2 theta minus 30 equals to tan inverse of root 12, and therefore this gives us 2 theta minus 30 equals to, let's look at the tan inverse of root 12. What does it give us? So the tan inverse of root 12 from the calculator, this gives us 73.8979. So we'll have 73.8979 degrees. Now already we have the basic angle, so we can consider the unit circle. Tan is positive in the first and third quadrant. So in the first quadrant already we have 73.8979. We can also get the corresponding angle in the third quadrant. So in the first quadrant we have theta. In the third quadrant we'll have 180 plus theta, where theta is the basic angle in this case. So this means that we'll still have 2 theta minus 30 degrees equals to 73.8979. The corresponding angle in the third quadrant will be 180 plus 73.8979. This one will give you, we'll have 2 theta minus 30 equals to 73.8979, and if we sum these two, it's going to give you 253.8979. Now what we can do here, we can add 30 degrees to both sides, so plus 30, and also here plus 30, so that what we are going to have as the next step, you'll have 2 theta equals to 73.8979 plus 30. This gives you 103.8979, and 253 0.8979 plus 30 gives you 283.8979. The next step, we can reduce both the left hand side and right hand side by 2, or we can divide through by 2, and therefore we'll have divide this by 2 by 2 by 2. Dividing this by 2, we'll have the value of theta to be equals to, having the calculator, we'll have 103.8979 divided by 2. This gives you 51.9489, but we can express to one decimal place, that is 51.9 degrees. On the second part, you can also get our calculator. This gives you 283.8979 divided by 2. It gives you 141.94895, but we are required to give to one decimal place, so therefore we'll have 141.9 degrees. We can also do the same when tan of 2 theta minus 30 is equivalent to negative root 12. So part 2, we'll do the same when tan of 2 theta minus 30 is equivalent to negative root 12. And in this case, still we'll get the basic angle. Therefore, we'll have 2 theta minus 30 equals to the tan inverse of negative root 12. And from the calculator, we can also have the tan inverse. So the tan inverse of negative root 12 we'll have this as negative 73.8979. So we'll have this still as 2 theta minus 30 equals to negative 73.8979. Now, since the angle is negative, we go back to our unit circle. We go back to the unit circle. Tan is only negative in the second and in the fourth quadrant. And we know that in the second quadrant we'll have 180 minus theta, and in the fourth quadrant we'll have 360 minus theta. Now if we substitute these two, then this is what we are going to have. Remember, the negative shows the quadrant in which tan is negative, so therefore we can have 2 theta minus 30 equals to 180 minus 73.8979, and also the corresponding angle in the fourth quadrant will be 360 minus so this one should be 360. So this is the same as 360 minus 73.8979. Now this one will be equivalent to 2 theta minus 30 equals to, let's get the difference. The difference in this case will have 180 minus 73.8979. This gives you 106.1021. 106.1021. Then we can also do the same for 360. The second part we have 360 minus 73.8979. So this will give you 286.1021. So 286.1021. What we can do, we can get rid of this negative 30 by adding both 30 to 106.1021 and 286.1021. So here we can add 30, and also the second one we can add 30. So that what we are going to have here is 2 theta equals to, this one should give you 136.1021, and this one should give you 316.1021. We can divide through by 2 so that the angle here will have 136. Let's start with 136.1021. 136.1021 divided by 2. This gives you 68.05105, but we can give to one decimal place, which is 68.1. So we'll have 68.1 degrees. And also we can have 316 as the second value, 316.1021 divided by 2. This gives you 158.05105 as displayed in our calculator, and therefore to one decimal place we'll have 158.1 degrees. So therefore all the values of theta will be 1. We will have the first value here is 51.9 degrees, the second value 68.1 degrees, the third value 141.9 degrees, and the last one is 158.1 degrees. So you have to give all the 4 values, and therefore this is our solution to part A. Part 2, Roman 2, this is what you've been given. Solve for 2 tan x sine x plus 3 equals to 0. So Roman 2 here will have 2 tan x sine x plus 3 equals to 0. Plus 3 is equivalent to 0. We can use the blue pen. Now simplifying this, I want us to just recall some few things. We know that tan x is equals to the ratio of sine x over cos x. So therefore we can incorporate this one. So instead of having tan x, we can replace with sine x cos x, and therefore we'll have 2 sine x over cos x sine of x plus 3 equals to 0. Removing cos of x in the denominator, this one will be the same as 2 sine squared x plus 3 cos x equals to 0. Number 2, we can also recall this by the identity sine squared x is simply equals to 1 minus cos squared x. So replacing sine squared x with 1 minus cos squared x so that we have a uniform trigonometric ratio, we'll have 2 into 1 minus cos squared x plus 3 cos x equals to 0. Expanding by removing the bracket, we'll have 2 times 1 gives you 2 minus 2 cos squared x plus 3 cos x equals to 0. We can rearrange this equation by getting rid of negative, so that what we'll have, if you reduce everything by negative 1, then we'll have 2 cos squared x minus 3 cos x minus 2 equals to 0. Now this is a quadratic equation, and if it is a quadratic equation, we can solve this one by product sum rule or substitution. We'll have, we are looking for two numbers whose sum is negative 3. So the sum here is negative 3, and the product is equals to 2 times negative 2 is negative 4. So in this case, the factors will be negative 4 and positive 1. Now, splitting, we can split the middle term because we know negative 3 is from negative 4 plus 1. So if we split the middle term, we are going to have 2 cos squared x minus 4 cos x plus cos x minus 2, and this one should be equals to 0. Factorizing by grouping the first two terms and the last two. The first two, the common term here is 2 cos x. So therefore we have 2 cos x into cos of x minus 2. The common factor here between cos x and minus 2 is positive 1. So this one will be plus 1 into cos of x minus 2 equals to 0. We have two brackets which are similar, so therefore we'll just pick one. Whatever remains outside the bracket should also be brought together and bracketed. So we'll have 2 cos of x plus 1, and second bracket we have cos of x minus 2, and this one should be equals to 0. Now if we set the two brackets to 0, then it means we'll have the first bracket will have 2 cos of x plus 1 equals to 0, and therefore we'll have cos of x equals to, this one gives you negative a half. If you set the second bracket to 0, we'll have cos of x equals to 2. What we can do here, we can reject or ignore. So in this case we just reject because we cannot get the cos inverse of positive 2. Now we are remaining with the negative a half. Now we can get the basic angle in this case, the basic angle, and the basic angle for negative a half is simply negative 60 degrees. So we'll have x should be equals to the cos inverse of negative half, which is just the same as negative 60 degrees. Now going back to our unit circle, cos is negative in the second and third quadrant, and remember the range in this case we are given in terms of pi radian. So in the second quadrant we'll have pi minus the angle theta, and in the third quadrant we'll have pi plus the angle theta. Now substituting this, we'll have the value of x to be 1. In the second quadrant this one will be pi minus 60 degrees is the same as pi over 3 minus pi over 3, and in the third quadrant we'll have pi plus pi over 3. Simplifying this further, we'll have x to be equals to 2 over 3 pi and 4 over 3 pi, and this is our final solution for question number 8.